Just to introduce Lisa quickly, she's a distinguished professor of biological oceanography, founder of the DOSI, and she's just a great person altogether, being continually awarded and getting these different achievements. She knows Namibia well, she's been here, she's worked here with us, and she's just a great person. But she's been involved with deep sea mining for quite a while. I'm trying to get full screen. Are you seeing full screen?
Not yet. No.
Yeah, okay. So I will rush through this. I know people, there's a picture of Lisa, and she apologizes. She said she wished she could be here. So sea mining impacts very similar to what we've heard before, but a big concentration on the plume effects. By the way, she did these slides completely independently of me, so I think we're seeing common ground. Again, the UNCLOS requirement to prevent harmful effects, and we have to try and describe this. So these have got to be avoided through all phases of environmental management, from the tier at the top in the strategic environment assessment, down to regional environmental plans, down to environmental impact assessments, risk assessments, and right down to monitoring. We've seen the different environments for global deep sea mining. We can alter the substrate, of course. We can alter the geochemical underpinnings that are very important in the anoxic or the low oxygen or sulfidic environments. The loss of the biogenic habitat. Often these habitats give place to other small animals living in amongst them, so that has to be remembered. What's happened now? So some of the efforts have been to set aside areas of particular interest, the environmental goal setting and objectives, regulations, EIAs, etc., etc. But we really need to define what harmful effects are, serious harm, significant adverse impacts. These words are bandied around in the regulation, but do we really know what they mean? So according to UNCLOS, serious harm must allow the council to actually disapprove areas for the exploitation. It can deny application. It must cause areas to be set aside for no mining. It should induce emergency orders to suspend. And an interesting one, it should hold the countries to a liability if they do cause serious harm. So how do we operationalize this term that has been used all the time called serious harm in seabed mining operations? And the operators need to know this. Mining does cause harm, but how much is acceptable? Identify the thresholds and the triggers and recognize the context dependence. In other words, where are you mining? What sort of, what are your priorities there as far as the ecosystem or the ecology goes? And very importantly, incorporate cumulative impacts. So identification of serious harm requires these goals and objectives. And again, these words are used, standards best practice. Well, what is standard best practice for deep sea mining? Necessity for policy development and scaling up. If things scale up from these really startup ventures that are being attempted at the moment, what when full-scale mining across the globe happens? Level playing field, everyone must know what the rules are. Common heritage, whether that's future generations anywhere in the world, and the contributions, of course, to the sustainability development goals. So we need to get explicit conservation objectives in this. The draft regulations that have been put together by the International Seabed Authority, serious harm, they call it, they must not represent a significant adverse change. So what exactly do we mean by this in the context of serious harm caused by seabed mining? And how are rules going to be set according to that? There is a paper that was done in 2016, is widely quoted, but it elaborates all these different kinds of serious harm that can come about with seabed mining. The connectivity between regions where you're going to mine, the cumulative impact. It's fine to just have one mining activity, but as soon as more are allowed, then the effects are going to coalesce, and soon we've got a much bigger problem that we had with just one mining activity. And these places have been definitely eyed for mining, and it will increase. So the environmental objectives need to guide our blue economy, the buzzword of the moment, just like having sustainable development goals for deep ocean. Protect the ecosystems, maintain the ability of populations to replicate, to replace themselves. Very important to humans, maintain the ecosystem functions from the ocean, genetic diversity, etc. Sustain the ecosystem services, that is supporting the ecosystem functions. Resilience, how resilient are these systems for recovery? One of the questions we've just had. And of course, incorporate the uncertainty into the risk assessments. So the leading biologists and lawyers are trying to hammer out the environmental goals and objectives in the ISA presently. Of interest, of course, to the biological scientists to sustain the marine, benthic and pelagic ecosystem integrity, including the physical, chemical, geological and biological environment. Protect the ecosystems from contamination, something we've been talking about today. Maintain the ability of populations to replace themselves. And here we have a little bit more elaboration on the list that we've seen before. So scientific knowledge, I'm sorry I am rushing this, but I know people have time restraints. The regional distribution of habitats. Identify unique features in the region where the mining is going to take place. And these will be vastly different in the different regions. Natural variability, the connectivity, the succession, the endemic species in that area. Again, coming up, the ecotoxicology of the plumes. And this can be done experimentally. Interactions with fish and fisheries, extremely important in the Namibian case. Faunal sensitivity to inevitable changes in substrate and chemistry. And these other impacts, interactions.